And I will briefly present here a piece of work that we just put together above the Notre Dame vaults. So I'm Renato Saleri. I'm Italian, as you might hear, because I have an Italian accent. And I'm an architect and a researcher at the MAP lab. I'm responsible also for the drone platform of the lab. I contribute to the scientific project at Notre Dame by developing a tool, in this case, for the periodic survey of the extradores of the vaults, the upper part of the vaults of Notre Dame. And we know that this place during the fire of April 2019 has left a large quantity of debris of the arson, of the burning, of the roof, and of all the wooden frames that were in place at that time. So I won't repeat what has been already clearly explained by my colleagues just before, but so the scientific site of Notre Dame collects and processes very large volumes of data. And of all kinds that must be interpreted and by all those teams that work together on the site that represent quite a lot of people working together. I think we do not want to build here a virtual and hyper-technological tower, Babel Tower, obviously. So we're trying to keep the connection in a good state between all of us that are working together. So as we said, we have 3D point clouds, we have pictures, we have 3D meshes, we have textual annotations, chemical analysis, and specialized sound samples. So many things that we have to gather and to put together in this big building, scientific building that we are just experimenting. So in particular, in this case, the wooden structure working groups need the most accurate 3D inventory of all of the building all the time. So that's why we speak about multi-temporal 3D survey. That's what we're going to put together with this small, tiny example of the cable cam. So in order for this data to be usable, all this data must be comparable, which implies as possible and homogeneous data sources that are, if possible, identical through time. So we must be able to count in photogrammetry, especially, as my colleague Antoni just explained, that the picture campaigns carried out, if possible, in the same spatial and light conditions to be comparable, to be reliable. The MAP has been using drones for many years, since 2002, 2003, and Massimiliano was a very friendly witness of our first attempts with the flying machines many years ago. But here you see that the special context of the Notre Dame vaults is quite busy, because you cannot use drones in this very specific configuration for the exhibited, of course, of the survey sites. For the temporary obliterating obstacles that happens to be in this tiny space. The masking phenomena of satellite constellations by this huge wooden roof that was put in place for consolidation purposes. And here, obviously, also some complex beyond line of sight flights that would occur in case we use some drones. So, which made the use of drones in this case quite tricky. Next slide, Valeria, thank you. So that's why we ask, obviously, why we cannot use drones. And I will show you, because besides we use a drone on the lower part of the vault in Notre Dame, but we use this specific little drone because it has this peculiar ability to move its camera upwards so that we were able to take pictures of the lower part of the vault. Next slide, please. So, in the particular context of the Notre Dame construction site, and in order, as I said before, to repeat all the campaigns, the photographic campaigns, in good conditions, it has been necessary to develop a specific tool, specific method that could be implemented by non-specialist operators, be adapted to a particular operational context. Remember all the decontamination processes that occur when you have to go from one side to the other of the work site, because you had lead, you have many difficult conditions that must be taken into account. It must be also reliable and safe. Yes, the autonomy of embedded systems by, you cannot go back, you cannot go outside for change or charge a battery, change a SD card. So it's quite difficult to operate in this context. And we have also said that the photogrammetric survey campaigns requires an optimal shooting conditions. So we will try to guarantee an homogeneous as much as possible of the positioning of the cameras, and make sure that all the pictures are taken in good conditions, distance, coverage, lighting, and so on. So next slide, please. So that's why we opted for a cable cam, which looked like something quite interesting for this specific case, and could have many advantages regardless of the use of a drone in this very special environment. So we can say that what brought us to choose this specific type of device is that it's an existing technology which is immediately available. You can put all those cable wherever you want, so you can repeat the trajectories as many times as you want. Dimensions are rather small, so you can control it in some difficult parts of this survey site, which is very exiguous, as we saw before. It can be obviously remote controlled, and also remote controlled if it is out of the line of sight, because you still have the video signal on your remote control. And you also can have programmable flight paths, so to define the speed and the direction. So these are all items that you can control prior to the survey. So next slide. Yes, you can slide all the topics that I will talk about. Thank you, Valeria. The specific difficulty in this part of the survey site is that you have very often a short distance to the subject, because the vaults are quite high, so there might be some issues with this. You may interfere also with ongoing clearing operations, because there are operators always all day time on the site. And the specific model should be controlled by several operators at a time, which could be also an issue in the specific work conditions. And in these conditions, also the coordination between these three elements makes it difficult to control all the parameters of shooting pictures, like inter-image overlap factor, and so on. And so this is obviously is quite fundamental in photogrammetry, as you might know. So next slide. And among all these operational constraints, we have all the the position of existing debris that can partly mask many sites, many regions of the place of the surfaces that you have to survey, which could be quite difficult. You must have to multiply all the shots as much as possible in order to reduce those self-occulted zones that may occur in this case. Some other elements present a strong vertical extension, which goes sometimes even above the level of the camera itself, so you won't be able to see those elements in the survey campaign. For us, it was the prohibition to access directly to the site. We could not hang above the vaults directly, so we had to form all these operators to be able to put in place this specific systems. So due to this configurations, a permanent visual control is quite impossible for even small people, and I don't say this because I'm quite small, but this is quite difficult to keep a permanent contact with this device. And so this led us to the opportunity to develop something custom on the side and more suitable to the needs of this very specific survey campaign. So next slide presents here, as we simulated the operational limit of this previous cable cam, which hangs quite a lot below the cables and makes impossible to survey those yellow areas that you can see here, because they protrude too much and you would not be able to fly over these spots. So we had to develop something custom and more accurately designed for these operations. And next slide, Valeria. Thank you. So that's why we built this custom object, custom cable cam, which was a greater use for non-specialist operators. So it must be very simple to use and to handle on the site. Better capacity and mass distribution as well. We changed the location of the batteries because we had a better hanging action. And so we had to design a few other custom topics, items to be able to use this device over the vaults. And as I say, it's an easy to pack, ready to go solution, as you might see on next slide. Between inside, so you can change the slide. Thank you, Valeria. Right, we have here this all packed all the items into this small case that could be easily transported from one part of the site to the other and pass all the decontamination process, which was quite easy to use at that time. On the next slide, you will see our friend Alexis Komenda, which is also the official photographer of the Notre Dame working sites, who provides very nice pictures of the campaign in progress, and you will have a very nice picture of Alexis Komenda at the end of this presentation. So you see here the context of the presentation. Just to finish the previous, yes, excuse me. The context of the operations, which is quite tricky if you want, because the site is very exiguous and you don't have much place to store and to move. So that's why it was quite complicated to operate right here. So next view, we have also, besides this hardware specific design, we have also this piece of software that was specifically designed to this for this campaign, and which introduced this specific way to model the frustum of the cameras. and to switch to replace this frustum with a light source in a 3D software, like it's done in Maya, which is a very common 3D modeling software. So we consider that we can simulate the side of view of the cameras by replacing the frustum of these cameras, specific cameras, by an exact physical light source, which have exactly the same geometric characteristics of this frustums, of this camera frustum. So you can visualize and predict the coverage of the cameras, in this case, the upper part of the vaults of Notre Dame. So we are thus able to play with this virtual installation and visually appreciate the best angle of view, also horizontally and vertically, and the best placement of the cameras under the cable cam. This is done to estimate the best ratio of movement speed and trigger interval of the cameras and the pictures to be taken in this specific place. So if you switch to the next slide, Valeria, yes, here we have all the items. Thank you, and you can launch the short video in this case, right? So this is, you can appreciate visually what this reverse camera, as we called it, can do, is that you have this frustum modeled by a beam of light, and that shows exactly what the camera will see if it was placed in that very position on the upper walls. So in this case, you can appreciate exactly the size and the efficiency of a camera coverage in this case, because obviously we cannot make many tests. We have to go there with the cameras ready, with the cable cam ready, and all set to start the survey, so we cannot perform multiple tests before the mission, before the actual mission. So if you finally, next slide, Valeria. Finally, we only positioned the cameras from side to side, because it was not possible to put the camera on this longer tracks, because all the operators were often crossing that area, and it was impossible to put the cable cam in this part of the vaults of the cathedral. So next slide. I think I'm hoping not too long. So here briefly, what was the best position for the cameras? So like you see here, we had to develop a head support for those cameras, for those back-to-back cameras, spinning at 90 degrees at the end of the line, so that we thought it could cover most of in the best way, the upper part of the vaults. And this is quite simple. I don't know if you see the video, because I have the camera here in my hands, and I can just show you the way it works. But I promise it works. It works fine. And it was especially with a very simple gravity action systems. And as you know, gravity never falls, never fails. So it could not fail actually on the mission side. And next slide, Valeria. So we have here a view of the first version of this cable cam. You can see two cameras below the cable cam, which is a small video that you can trigger if you want. Yes, thank you. So this is one of the first survey campaigns we did, and we noticed that the two cameras back-to-back solution was not efficient enough for the purpose we wanted to perform in that case. So we developed, next slide. So we tested here with this piece of software the effective coverage efficiency of the back-to-back, the two cameras mount. And if you go to the next, right, you have the next step of design, which was performed with this 3-head cameras. As obviously, the more cameras you have, the best coverage you will obtain, obviously. But in this case, we also experimented these three cameras configurations, as you might see on next slide, if you mind, Valeria. So here we have a small test with the three cameras, and we have a much better coverage of this particular area, which is right below the cable, which was not covered sufficiently with the two cameras device. And you can also go to the next slide, as we show here the resulting coverage when we put together all the different simulated camera position in this case. And you see that the middle part, so the part which is exactly under the cable, is much better covered by the three cameras, as you would expect, obviously, and which did most of the job in this case. And if you go to the next slide, once again, so you have here the general diagram of the positioning and the overlapping of all the cameras together. And if you compare the lower left image of the coverage of this area, you can see that it looks very close to the aftermath representation of the camera's coverage in a meta shape in this case, and those two representations look quite similar. So we can say somehow that our predictive tool was quite efficient in this case. And you can go to the next slide. So here we have another view of an example of the fourth photogrammetry mission, well, done in this case with reality capture. And on the next slide, you have a brief preview, some tech drawings of this specific mount. So you have the cable cam, which is a commercial robotic design, the one you see on the top, something that we bought from a Spanish company who builds many devices like this for action cams, sport filming, and we developed all the lower part that you can see here, and was custom developed and built in our laboratory here in Lyon. You have also some details of the lower part where the three cameras mount, just on the right. And as I said, if you switch to the next slide, we could do several different missions on this site. I think you have another page just before. No, this is the last one. Excuse me. You have the right page just before. So you can see that we started on March 10 of 2020, and was just before the big confinement that we have, and for almost 2 months and a half we could not go back on the site again. So we had a big temporal gap here between those two first missions. But after that we could go on the site every 2 weeks almost. So we have surveyed here the different parts of the upper walls, and you can also see all the results of all of these campaigns in the Notre Dame viewer that might be introduced and presented later in this conference, I think. So the last one is from 8th of December 2020, as you see. We also did on the 17th of July 2020, we had this drone survey of the lower part of the vaults, which can be seen here. And so next picture and last picture. So this picture from Alexis Commenda, who helped us a lot in these missions, and I would like also to thank. And so is the end of my presentation. Thank you to all of you very much again for this little issue, this little problem in sharing my screen. So thank you.